In this video, we're going to talk about practice problems for MTE 5, linear equations, inequalities, and systems of equations in two variables. First, we're going to talk about naming ordered pairs. We're going to look at the ordered pair for the point labeled number 7. The x-coordinate is -3. And the y-coordinate is a +2. So the name of that ordered pair is -3, 2. Next, we're going to talk about an x, y table. Lots of times we're going to write it as a t table like this, x over here, y over here. I'm going to rewrite it like that because that's typically how you're going to see it in class. So we want to plug x in and find y. Since x was given to us, let's go ahead and let's solve for y. Let's actually find ordered pairs that satisfy equation 2 first. Let's solve for y. X plus 5y plus 10 is equal to 0. So that's going to be x plus 5y is equal to -10. 5y is equal to -x minus 10. Y is equal to -1/5 x minus 10. Now, since all of my y's are integers, the only chance of that happening is going to be if x is a multiple of 5 to get rid of this fraction. So I don't need to test A. I don't need to test, I can test B. B might work because 0 is a multiple of 5. Let's take a look at, I don't need to test D though, because 4 is not a multiple of 5. So let's look at B. Is 0 minus 10 -2? No. Is 1 minus 10 equal to 10? No. So which of these is supposed to be the answer and is not? Oh, there we go. That's the problem. -10 divided by 5 is -2. So 0, -2 is our answer. Let's check the others just to be sure. 1 minus 2 is -1, not 10. Okay. Now let's go ahead and y is equal to -2x plus 1. So when I stick in my x, get y. I'm going to subtract 2 as I go along. I'm going to add 2 coming this way. And then I'm going to sketch a graph of my linear equation from these ordered pairs. 0, 1, 1, -1. This. 2, -3, -1, 3, and -2, 5. Okay, there we go. Moving on to the next page. Find the value of f of x. This is function notation. It was 2x minus 1 at x equals 6. So f of 6 is going to be 2 times 6 minus 1. It's going to be 12 minus 1. F of 6 is going to be 11, which means that there's an ordered pair on the graph 6, 11. estimate the x and y intercepts of the graph. So the y-intercept is right there at 0, -2. The x-intercept is right there at 1, 0. Graph the linear equation by plotting the x and y intercepts of problem number 6 asks for -2x plus 4y minus 16 equals 0. Let's make this -2x plus 4y equals 16 to make it a little easier for us. When x is 0, 4y is equal to 16 and y has to be 4. When y is 0, -2x is equal to 16 and x has to be -8. So we want 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3, 4. Until I don't have any graph paper on this. There we go, on this drawing. Whiteboard, that's okay. Let me clear my drawings here. Okay, number 7 asks us to sketch the graph of y equals 2/3 x plus 2 using at least 3 points. So I'm going to use 0, 2. Then I'm going to go right 3 and up 2. And I'm going to go left 3 and down 2 because of my slope that tells me to rise 2 and run 3. So take a look at the multiplication if you're unsure. 3 goes into -3, -1 times. -1 times 2 is -2. -2 plus 2 is 0. 0 times anything is 0. 0 plus 2 is 2. 3 divided by 3 is 1. 1 times 2 is 2. 2 plus 2 is 4. So we should get our y-intercept of 0, 2. We should be able to go over to -3, 0. We should be able to come over to 3, 4. We should all be on the same line. There it is. And we're done with problem number 7. Problem number 8 asks us to graph the constant function y is equal to 4. It's going to be a horizontal line through 4. Maybe when x is equal to 5, it's also 4. When x is equal to -6, or for any other x value, y is also equal to 4. Number 9 asks us to graph the vertical line x is equal to -3. There it is. Let's go ahead and erase those drawings now. Lots of sketches in this, so I'm going to have to draw and erase quite a bit today. Now we're going to sketch the graph of the linear inequality 3x minus 2y is greater than or equal to 6. To do that, I'm going to use the intercepts here. When x is 0, y would be -3. When y is 0, x would be 2. This is going to be a solid line because it says or equal to. So there's my boundary line. Now I need to know whether to shade above or below that line. To do that, I'm going to choose the origin as a test point because it's not on the boundary line. So when I test it, is 0 greater than or equal to 6? That's false. I want to shade on the true side. So this side is false. which makes this side over here true. I'm going to shade on the true side over here. So that's my answer, is the boundary line and shading beneath it in this case. Sometimes you're going to shade above, sometimes you're going to shade below. So number 11 asks us to find the slope if possible for the line passing through 4, 7, and 5, 10. So my slope is equal to y2 minus y1 over x2 minus x1 is 3 over 1 is 3. Number 12 asks me to find the slope of negative 16x plus 1. This is my slope because it's in y equals mx plus b form. M is my slope. So there it is. My slope is negative 1/6. All right, let's erase a little bit more. Number 13 asks us to take the equation 5x plus 8y equals negative 7 and to convert it into slope-intercept form first and then find the slope. We're going to do that by solving for y. So we're going to subtract 5x from both sides. 8y equals negative 5x minus 7 and divide by 8. Y is going to be negative 5/8x minus 7/8. And that tells me that my slope is going to be negative 5 over 8. Now let's find the slope of the given line in this graph. My slope is going to be my rise over my run. So looking just at my intercepts here, that I'm going from negative 2, 0 to 0, 2. My rise was 2, my run was 2. 2 divided by 2 is 1. So I'm going up 1, right 1, up 1, right 1, up 1, right 1. Number 15 asks me to find the slope of x equals negative 8. Well, I can't because that's undefined. Vertical lines have undefined slope. But horizontal lines, like number 16, have a slope of 0. So I can't divide by 0. There's no change in x. That's an undefined number. That's why the slope for number 15 is undefined. But when the numerator of the fraction is 0, 0 divided by any non-zero number is 0. For number 17, they give us the y-intercept here because the point is given where x is equal to 0. So we can just write our slope-intercept form like that from the given slope and the y-intercept. Right. Moving on to number 18, write the equation of the line that passes through the point 5, negative 5, and has a slope of negative 5. So we're going to need to use point slope form here. Point slope form is going to be used in many of the rest of the problems here. It is y minus y1 is equal to m times x minus x1, where x1, y1 is a given point on the line. And then we want to solve this for y to get the equation in slope-intercept form. Which, remember what slope-intercept form is y equals mx plus b. So that's our objective for the next several problems. We're also going to talk about parallel lines have the same slope. Perpendicular lines have slopes that multiply to give me -1. But we're going to use point slope form of the line in most of the problems on this page. So we have y minus a -5 is equal to -5 times x minus 5, y plus 5 equals -5x plus 25. Subtract 5 from both sides, and y is equal to a -5x plus 20. That was number 18. Number 19, pass to write an equation of a line that passes through the point -1, -10, and -5, 2, and write the equation in slope intercept form. So we have our slope is 2 minus a -10 over -5 minus a -1 is 2 plus 10 over -5 plus 1. 12 over -4 is a -3. I'm going to show you there is something else that you can do since I know that I'm going for slope intercept form. It's okay to write this as y equals mx plus b, and to take either of the xy ordered pairs, I'm going to take -1, -10. Sorry. Like this, and I can come back and write my answer like this. Let's go back though and show you with point slope form that I should get the same thing, because the goal here is to use point slope form when you're given a point and the slope. So y minus y1 is equal to m times x minus x1 wish my eraser was a little thinner on this. And we get the same answer. All right. That was 18 and 19. On to number 20. 20 asks us to find the line passing through the points -5, 7 and -5, 2. Notice the x coordinates are the same here. X is equal to -5. There was no change in x. 21 asks us to find the equation of the line passing through 1, 2 and 14, 2. Notice that y is the same here on both of these. Y did not change. Y is equal to 2. 22 asks us to find the equation of the line passing through the point 4, -2, and parallel to the line -5x plus 6y equals -2. So if I find the slope of this line, the slope of the line we're trying to find needs to be the same because parallel lines have the same slope. 6y equals 5x minus 2. Y equals 5, 6x minus 1/3. So 5, 6 is my slope that I want. Y minus y1 is equal to m times x minus x1. Minus 10 thirds. Y is equal to 5, 6x minus 16 thirds. And we'll move right along. Number 23 asks us to write the equation of the line that passes through the point 5, 3, and is perpendicular to negative 3x plus 7y is equal to 5. So our slope of our perpendicular line is going to be 3/7. So we need to find the slope that's perpendicular to this line. It's going to be the negative reciprocal. So my slope that I want over here is going to be negative 7/3. So y minus y1 is going to be m times x minus x1. Y minus 3 equals negative 7/3 x plus 35 over 3. I'm going to add 9 over 3 when I add 3 to both sides. Like that. All right, number 24 introduces us to the idea of systems of equations where the solution needs to be true in both equations. I'm going to tell you something interesting about systems of equations. For lines, systems of equations are either going to be like this, where they're parallel. And if they're parallel, these are independent equations because they're separate lines, and they're inconsistent because they don't intersect each other. So I could also have lines that are independent and consistent because they're different equations that have only one point of intersection. They have, they do cross each other, or I could have lines that are actually the same line that lie right on top of each other, and they have every point in common. And those are called dependent when they're the same equation. And of course, they're consistent because they have infinitely many points of intersection. So I either have no intersection, no solution. I'm going to have a finite number of solutions, in this case, 1. But we'll see some other systems of equations later in Algebra 2 that have more than one answer to them. Finite number of solutions, or this one has infinitely many solutions. Okay. You'll see this in some textbooks called a contradiction. This will be conditional because it's only true under the condition of that x value equals that y value right here, and this being called an identity because it's always true. Now we're going to take some points. We're going to see if they make them true, but using what we know here, either we either have a situation where none of the points will work because they never intersect, or maybe one of the points will work if they have different slopes from one another, or all of the points will work if, and this is when we have the same slope, but we have different y-intercepts. This is when we have different slopes. And this is when we have the same slope and the same y-intercept. let's figure out which type of system of equations we have, and that'll tell us how many solutions to expect. And then we'll know, for instance, if we're only looking for one answer to the problem. Okay, so the slope of our first equation, 7y equals negative 4x, y is equal to negative 4/7 x. That looks pretty different from 9y equals negative 2x minus 22, y equals negative 2/9 x minus 22 over 9, right? These are different numbers, so they're not the same slope. So I should have a situation where, let's see, these are both negative this time, where I have a single point of intersection. All right, so if I find one answer, it's the only answer, and I don't have to look for any other answers. I think from the equation that I see here that this one might be a possible answer, because I'm going to need an x value that is a multiple of 7. I don't see any of the other ones that look like x is a multiple of 7. So let's try this. When x is 7, y is negative 4. That's good. Let's try x is 7 here. Negative 2/9 times 7 minus 22 over 9. It's negative 14 over 9. Minus 22 over 9 is a negative 36 over 9, is also a negative 4. So 7, negative 4 is the answer to the system of equations. They wanted you to try all 5 points there. We don't need to try all 5 points because we know only one of those points can be the answer. Now we're going to sketch the graph of x minus y equals 2. So when x equals 0, y equals negative 2. When y equals 0, x is equal to 2. So there's this line. And then there's the bottom line is, draw it in a different color here. When x is 0, y is 2. When y is 0, x is 2. And we have the point where the black and red lines are the same right there at 2, 0. Let's stick it in and see if that's true. That 2 minus 0 equals 2 and 2 plus 0 also equals 2. They're both true, so the point 2, 0 is our solution. We don't usually like to use graphing because graphing is only good for us if it crosses exactly at tick marks there. We can't really eyeball it very well if it falls between tick marks. So we're going to use some other options like substitution and addition, or this one is also called elimination sometimes. So let's talk about when we use substitution and when we use elimination, because they're the algebraic means in which we usually solve systems of equations. So this one that has coefficients of 1, it's easy enough for me to solve for one of the variables. Let me solve for y. Y is equal to negative x minus 2. Now that I've solved for y, because at the point of intersection, the x's have to be the same and the y's have to be the same, the y in equation number 2 has to be the same as the y in equation number 1. So I'm going to replace the y in equation number 1 with what it's equal to in equation number 2. And that's going to eliminate a variable for me. Now I'm going to distribute. And then I'm going to come back and I'm going to solve for y. The opposite of -3 is a +3. So y is going to be 1. So I should have the point -3, 1. Let's check it out here. -6 minus 3 is -9. -3 plus 1 is -2. Check. That made both equations true. Let's give myself a little bit more space here to work my elimination method. Elimination or addition is the method that we're usually going to use because we usually don't have coefficients of 1 to start off with. Though it works very nicely for us when one of the coefficients is 1, and I'll show you why that is right here because it gave us one like that. Okay, so what we're looking for is we're looking for if there's already coefficients that are the same but opposite sign, that when I add them I'd get 0. If not, I'm going to try and multiply the top equation, bottom equation, or both equations by something to make signs like that that are equal and opposite. So I may have to find the least common multiple. We've practiced that already. And I just decide which variable I'm going to eliminate. In this case, it was easiest to eliminate b and solve for a. Now I can go back into either of the equations here and then go into the first one. 3 minus 2b is equal to 7, -2b is equal to 4, b is equal to -2. So my ordered pair AB is going to be 3, -2. Now we talked about consistent, inconsistent, dependent, so on. So I drew those pictures for you just a minute ago. Let's reduce that first equation into x minus y equals 1. And this is 2x minus y equals 6. It should be pretty clear that they're not the same equation, right? Because this would have to be 2x minus 2y equals 2 to have the same coefficient on x. They already have the same coefficient on y. They have different coefficients on x, different constants. So if I solve these for y is equal to x minus 1, y is equal to 2x minus 6, we're going to see that they have different slopes and different y-intercepts, but just this fact that they have different slopes means that it's going to be independent, consistent. Okay. Now we need some space to work here. We're given function notation again. F of x is equal to 3x minus 6, and they want us to evaluate f of 5. It's going to be 3 times 5 minus 6 is 15 minus 6 is 9. Then they want us to find f of -2. So 3 times -2 minus 6 is -6 minus 6 is a -12. They want us to find f of 2/3. So 3 times 2/3 minus 6 is 2 minus 6 is -4. F of 0 is going to be 3 times 0 minus 6 is 0 minus 6 is a -6. And f of 6 2/10 is going to be 3 times 6 2/10 minus 6 is going to be 18 6/10 minus 6 is 12 6/10. Now, when we look at the graph below, I'm gonna move in a little bit so you can see that here. We're going to look for f of -6. So -6 has a y value of -4. F of 0 has a y value of 2. F of -2 has a y value of 0. And f of 1 has a y value of, looks like 3. Okay. That looks like the same line that we had a while ago. That was y is equal to x plus 2. So if we would go ahead and stick in these x values, we should get these y values back out as well. We don't need to know the equation of the line, though, to read the ordered pairs off of the graph. Given this graph, find the x such that y is equal to 4. So I'm going to come to y is equal to 4 right there. I'm going to come down here, and it looks like x is equal to 3 when y is equal to 4. See that if I had straight edges here, I could come down to the point x equals 3. Now we're going to make some systems of linear equations, and then a system of linear equations for some word problems here. A hot air balloon at 1,020 feet is going to descend at a rate of 85 feet per minute. So write an equation that relates the height of the air balloon as a function of time. We just did that, the height at time t, and t has to be greater than or equal to 0 is the implied domain here, since time is never negative. We'll talk more about domain and range when we talk more about functions in MTE 7, 8, and 9. You invest a total of $5,800 in 2 investments. So that's going to be my first equation, is that my total of my 2 investments is $5,800. The first investment earns 3.5% interest. So there's my return on investment for investment X. And my second earns 5.5% interest on investment Y. And I want that to be a total annual income of $283. Now this is hard because it's got decimals. That's okay though. We're probably going to use substitution here because we have coefficients of 1 on X and Y. So let's go ahead and solve for, let's solve for X. X is equal to 5,800 minus Y. So when I do that, 0.035 times 5,800 minus Y plus 0.055 Y is equal to 283. So calculator, we're going to want to figure out here what 0.035 times 5,800 is. And that is 203 minus 0.035 Y plus 0.055 Y is equal to 283. So when I subtract, let's combine my like terms first. So this is going to be plus 0.02y is equal to 283. 0.02y is equal to, and then we're going to subtract 203 from both sides, and that's going to give me 80. Now, I don't like dividing by a decimal, so I'm going to multiply both sides by 100 here. 2y is equal to 8,000, and y is going to be equal to 4,000. I'm going to go for the easier up here and say if x plus 4,000 is equal to 5,800, then x has to be 1,800. We know that that satisfies the first equation, that the two add together to be 5,800. Let's check if 0.035 times 1,800 plus 0.055 times 4,000 is equal to 283, and it is. So there's our solution to our system of equations. That our first investment should invest $1,800. And our second investment, I'm going to not use parentheses or not use commas here, because commas are separating my X and my Y in my ordered pair. So I'm not going to use the commas for readability of big dollar amounts. We just have to figure out that that's $1,800 and that that's $4,000. Don't forget your units, though, that we are talking about investments of money. So we want dollar signs here. We don't need cents because these are both whole amounts of dollars. Okay, that is the last problem for MTE 5. When we come back, talk about MTE 6, exponents, factoring, and polynomial equations. Thank you.